Here's another question under motion. The motion of a body under gravity. This is a case of a bomb placed on a balloon. And while this balloon is at a particular point, some distance h above the ground, the bomb was dropped. And now we're to calculate the height of that balloon. At the point, the bomb or the balloon was at rest when the bomb was dropped. What is the height of the balloon above the ground? So we call the initial velocity u as 0 since the bomb was dropped at rest. The initial speed is 0. Now, of course, we know that the bomb is going to move downwards. It's going to accelerate in the downward direction. I'm going to take the downward direction as positive so that the acceleration due to gravity is taken as positive g, which is given as 10 meters per second squared. Okay, so we are told also that the time taken for the bomb to get to the ground from the point of release is 10 seconds. Okay, so from the second equation of motion, S equals ut plus half at squared. We're going to apply that and take this my S as the height of the balloon. That is the unknown or the required parameter. This is required, the height of the balloon above the ground. Now, my S becomes my H equals 0 times T, that's times 10, plus half times 10 times 10 squared. This is gone, so this gives me half times 10 times 100. So 2 here gives me 5. 5 times 100 gives me 500 meters. So the height of the balloon above the ground is 500 meters. That is to say, the time, suppose the bomb was dropped from rest. That is the height of the balloon. Now the second question, the part B, says if we should also calculate the height of the balloon above the ground, if it is ascending, suppose the balloon was ascending with a speed of 10 meters per second at the time the bomb is dropped, what is the height of the balloon above the ground? Of course, we know that when the bomb is dropped, it's still going to fall downwards. So I want to still give the downward direction positive, meaning my acceleration is really going to be positive g. That is to say, acceleration due to gravity acts downward. Then, remember that before this bomb was dropped, the balloon was ascending. That is, the direction of motion is upward. So it has this initial velocity in the upward direction before the bomb was dropped. So the direction upward this time around, I'll take it as negative, meaning that my initial velocity u is going to be negative 10 meters per second. So that from the same, we have to look for the height of the balloon, and at the same time, it takes 10 seconds for it to hit the ground, I mean the bomb. So from the same second equation of motion, half S equals ut plus half at squared. Now this is my h, the height of the balloon. This is now my minus 10 times t is 10 plus half times 10. My a now is positive g. And recall that g was given as 10 meters per second squared. So 10 times the same time, 10 seconds, so 10 squared. That gives me the height of the balloon equals minus 100 plus, this is 2 here, 5 times 10 squared, which is 100. That gives me h equals minus 100 plus 500. So the height of the balloon at the time, at the point where the bomb was dropped, is 400 meters. So given that the bomb, or it takes 10 seconds for the bomb to reach the ground, and while the balloon was ascending with a speed of 10, which means the height of the bomb and the balloon at that point is 400 meters.